if we may have example 13 extended or part B, we would wish to sketch the graph of y is equals to arc cosine x. And we need to realize that between 0 to pi, if that is the domain of y is equals to cos x, then we have one-to-one mapping. That means every value of x gives a specific value of y. It's a one-to-one mapping. And if we extend the graph beyond that to either 270 and 360, you realize that different values of x will give the same value of y, and in such a case, such a function does not have an inverse function. Please remember from our previous example, only one-to-one function has an inverse, and we can only have this from 0 to pi. Now, we know that this is the graph of y is equals to cos x. This is the graph of y is equals to cos x. And we know that for us to have an inverse, we need to reflect this graph along the line y is equals to x, the red line. Again, we know something, that during the sketch of an inverse function, the coordinates interchange. For example, you can see we had the range of all the way from -1 to 1 when we are dealing with y is equals to cosine of x. Now that range becomes the domain. That range easily becomes the domain. It becomes the domain of the function y is equals to arc cos x. So from -1 all the way to +1. Whatever was the range of the original function becomes the domain of the inverse function. So you can already see that we have coordinates pi over 2, 0, this particular point. And because it's going to be reflected along the line y is equals to x, then it gets to, this is pi over 2, 0. Then when it gets here, we need to talk about 0, because pi over 2, 0, if we interchange this, it's going to be 0 pi over 2. So 0 pi over 2. If we get here, we are going to have these coordinates, or pi 0. This coordinate is pi 0. So along the y-axis, it's supposed to be now 0 pi. So up there, this is pi. Conspicuously, when this point was at 0, 1, it's supposed to be reflected along this line, and it's going to be 1, 0 here. This point is supposed to be pi over 2 or 90, 0. It's supposed to be at 0 pi over 2. This point is supposed to be at the coordinate, this particular point is supposed to be at the coordinates pi minus 1. It is supposed to be reflected to minus 1 pi. So minus 1 pi. So what are we saying? What we are saying is that our new graph, let me put it in a different color. Our new curve is going to look like this. Our new curve is going to look like this. And that is this. This is just the graph of y. Y is equals to arc cos x. That is it, just the reflection along the y-axis. Along the line y is equals to x. But it is the graph of y is equals to arc tan that can be interesting, because we need to first of all get the graph of y is equals to tan x. And this one is going to be very interesting because we have asymptotes. We know one asymptote is around, if we have something like this, one asymptote is at -90, negative pi over 2. Another one is at positive pi over 2. Remember, this is the y-axis and this is the x-axis. if we can remind, we would wish to remind ourselves, we would want to know how does the graph of tan is equals to, how does the graph of tan look like? Of course, we know tan 0 is 0. So there. But as we tend to negative 90, the tan of negative 90 is not known. But as we approach negative 90, the tan of, let's say, negative 89 is minus 57.3. So such a big negative number. So we have a graph that looks like that. There are asymptote. This is an asymptote, and the graph does not touch this line, neither does it touch that line. Now, if we were now to reflect this one along the y is equals to x, first of all, if we need to get the domain of the original curve becomes the range of the inverse. So let's have it over here already. And this one makes us something to do with, let's have pi over 2, and let's have minus pi over 2. The domain of the original now becomes the range because it appears on the y-axis. But you can see the range of the original has no end. It has no end. That means the asymptotes already appear to be along those lines. The asymptotes appear to be along those lines. But please note, when this one is reflected along the line, y is equals to x, like we have here, like we may have the line y is equals to x, the line y is equals to x, our graph may have been forced to look something like something to do with, if we may have a graph that originally looked like that, and this is the line y is equals to x, you can already see that as it rests along the asymptotes and it's coming from a certain end, you can already see that this graph this way already comes this way, So we are talking of a graph that behaves that way and that way. So now that the asymptotes have been reflected along the line y is equals to x, then our new graph of y is equals to arc tan is this graph, y is equals to arc tan x. And that is just like it. Okay, it's not so much clear, but it is important to note that everything has been reflected along the line y is equals to x to get the graphs of y is equals to arc tan x. And there you go, all right?